Hello all. In this presentation, I shall brief you on ozone depletion. Now, as you all know, ozone depletion is a result of pollution. To be more precise, it is a result of air pollution. Now, I shall brief you on what is ozone, how does it protect us, how does it gets depleted, and how can we prevent ozone depletion. Now, what is ozone? Ozone is an allotrope of oxygen. The normal oxygen which we breathe in is O2, and ozone is an O3 molecule. 3 oxygen atoms are there. Alright, now this ozone is both harmful and it is both a harmful gas as well as a friendly gas. It depends upon where it is present. Now the ozone layer which protects us, which is very much needed for us, is present between the troposphere and stratosphere. Here, between the troposphere and stratosphere. Now the ozone layer present here is very much necessary for us. So it is a useful molecule there. When ozone is present between troposphere and stratosphere, it is a useful molecule. It is very much necessary for us. But when the same ozone is present near the Earth's surface, near the human beings, when the living things are in contact with the same ozone, it becomes toxic or poisonous. So we can say that the ozone present between troposphere and stratosphere is good ozone, and the one present near the Earth's surface is bad ozone. Now we know that ozone layer protects us from UV rays. Now this ozone layer which protects us from UV rays is only 3 millimeter thick. Imagine it's just 3 millimeter thick. Okay, ozone layer, the thickness of ozone layer is better described in terms of Dobson unit. So we say 1 millimeter is equal to 100 Dobson unit. So the thickness of ozone layer will be 300 Dobson unit. Okay, so imagine that it's only a thin layer, a 3 millimeter thick layer, which is protecting us. Now how is it? What is it protecting us from? How is it doing so? Why should it do so? The ozone layer protects us from UV radiation. The ozone layer present between the troposphere and stratosphere absorbs the UV radiation which comes from the sun, and thereby prevents the entry of UV radiation to the Earth's atmosphere. Now what is the problem if UV radiation reaches us? Or what is the problem if UV radiation reaches the Earth's surface? Now UV radiation can be classified into 3 types depending upon the wavelength. It is actually UV radiation. Ultraviolet radiation is an electromagnetic radiation, and its wavelength ranges from 100 to 400 nanometer. Now the UV radiation with wavelength 315 to 400 nanometer is called UVA, which is a mild irritant. Another one, UVB, with wavelength 280 to 315 is harmful to organisms, and UVC, radiation between 200 to 280 nanometer, is very deadly. It is this harmful UV radiation that is being absorbed by the ozone layer. When the UV radiation reaches the Earth's surface, it affects the living things and human beings and all living things. It causes skin cancer, skin irritation. Okay, sometimes continuous exposure to UV radiation may even cause genetic mutation, change in genetic gene code, that is genetic mutation may occur. So all such diseases and effects happens when UV radiation reaches, or when living things are exposed to UV radiation. So this 3 millimeter or 300 Dobson unit thick ozone layer prevents the UV radiation to reach us, thereby protects us. That's why sometimes we even call ozone layer as the umbrella of Earth, Earth's umbrella. Now, how is the ozone formed in the atmosphere? What happens when ozone absorbs UV radiation? Now, we know that oxygen is present in the Earth's atmosphere. When it comes in contact with light, it forms oxygen free radical, and this oxygen free radical and another oxygen molecule combine together to form ozone. So that is the formation of ozone. Now this ozone, when it absorbs UV radiation, it splits to oxygen free radical and oxygen molecule. This will combine with another ozone molecule and form oxygen. So this is the formation of ozone, this is the depletion of ozone. This happens naturally in the ozone layer, that is between the troposphere and stratosphere. The formation and depletion of ozone, natural formation and depletion of ozone, and this cycle is called Chapman ozone oxygen cycle. So in the nature, ozone is formed, it is depleted, so that the thickness of the ozone layer is maintained at 300 Dobson unit, nothing more, nothing less. So every extra ozone formed will be depleted, and for every depleted ozone will be formed. So this happens as a cycle, so we are not going to disturb it. It happens so, and the thickness of the ozone layer will be maintained. Now, how does ozone gets depleted, or what is ozone depletion? When the thickness of the ozone layer decreases from 300 Dobson unit to below 150 Dobson unit, then we say an ozone hole has been formed, created. So ozone hole doesn't mean that a big hole is formed in the ozone layer. Ozone hole is formed, we say it is the decrease layer. So when the 300 Dobson unit thick layer, that is the 3 millimeter thick layer, gets reduced to 1.5 millimeter thick, then we say ozone hole has been created. When the thickness comes down to 1.5 millimeter or 150 Dobson unit, the ozone UV radiation will not be possible. The UV radiation will pass through the ozone layer and reach the Earth's surface, resulting in all the diseases as we had mentioned earlier. Now that's how nowadays when we get exposed to sunlight during summer, particularly when there is a high temperature, we get sunburns. And we even hear now of heat waves and all, global warming, climatic change. All these are due to this. So what causes ozone depletion? It's the free radicals which we send out, which we emit into the atmosphere, that causes ozone depletion. And the free radicals come from all these compounds: oxides of sulfur, oxides of nitrogen, oxides of chlorine, which is obtained, which is formed from CFC, HCFC. CFC is chlorofluorocarbon, hydrofluorocarbon, okay, no chlorine here. Halogens, that is halogen containing carbon compounds. Now these CFCs, halogens, etc. are present in fire extinguishers, fumigants, air conditioners, body sprays, etc. The oxides of sulfur and nitrogen come from vehicle, automobile exhaust, industrial chimneys, etc. So we have to be careful. This oxides of sulfur and nitrogen also comes from burning of fossil fuels. This also causes smog. So we have to be careful for all these. We have to try to stop emitting all these chemicals into the atmosphere. Now, how does these chemicals deplete ozone or create the ozone hole? Let us take an example of CFC. CFC, chlorofluorocarbon, when it comes in contact with UV radiation, splits to chlorine-free radical and another free radical. Now this chlorine-free radical will combine with ozone molecule in the atmosphere to form ClO free radical and oxygen molecule. ClO free radical. This ClO free radical combines with oxygen to form oxygen molecule and again a chlorine free radical. So here see, this ozone has been used up. Now we are talking about one chlorine free radical. See here, this chlorine free radical is regenerated here. So once we set a single free radical or single CFC, if it produces one chlorine free radical, it starts depleting or using up the ozone molecules. So one CFC, this chlorofluorocarbon has 3 chlorine free molecules or atoms. So it can produce 3 chlorine free radical. So you can imagine the quantum of ozone which will be depleted. Now you multiply it. How many molecules of chlorofluorocarbons you have sent to the atmosphere? Okay, all these are going to use up the ozone molecule. So we have already sent to the atmosphere a lot of chlorofluorocarbons, lot of ozone depleters. Now what we can do now is, they are doing their work, they are depleting the ozone layer. Now what we can do is stop any more emission of ozone depleting molecules. So that can be done by stop using CFC, HCFC containing gadgets, use of renewable source of energy, say no to plastics, okay, plant more trees, use public transport, okay, and use eco-friendly household cleaning products, develop stringent regulation for rocket launches, etc. Or in other words, we can say that stop pollution. Now how can we, what are the substituents for these? Now we can substitute chlorofluorocarbons with carbon dioxide, with hydrocarbons. We can substitute chlorofluorocarbons in refrigerators and air conditioners. Alright, now there is a new substitution here. GAL is using a blend of isobutene, propane and propane as a refrigerant for the pentacool range of refrigerators. So that's an alternative method to chlorofluorocarbons. Alright, already started depleting the ozone layer. Now what we do? The depletion of layer. So to stop depletion of ozone layer. Thank you.